Hi everyone, our topic for today is density, a quantity that has been studied since the days of antiquity, and a topic that we will be looking at in greater detail as we strive to understand physics on a whole. Please remember to like, share, and subscribe, guys, and do not forget to click that notification bell. Density in physics is denoted by the rho, a symbol that looks like a common P but is actually the 17th letter of the Greek alphabet. Density can also be defined as a mass per unit volume of a substance, which basically means that it measures the quantity of mass that exists within a given volume of substance. The formula for density is rho equal m over v, where rho represents density, m represents mass, and v represents volume. The SI unit for density is kilogram per cubic meters, and this is as a result of what makes up density. Density is made up of mass divided by volume, where the kilogram comes from the mass and the cubic meters comes from the volume. Density can also be described as a measure of the proximity or closeness of the particles within a given substance. For example, object A is denser than object B because even though they occupy the same volume, the particles in A are closer together than those in B. This also results in object A having more particles within the same volume as object B, which ultimately makes it heavier. Denser objects will always sink beneath objects that are less dense, which is basically saying that objects that are denser than water will sink in water, but objects that are less dense will float. One should also understand that mass measures the amount of matter contained within an object, and volume measures the amount of space it occupies. That is, volume is just a fancy word for space. Let us analyze a few worked examples, which will allow you to see how we navigate calculations from this topic. Question 1 reads, an object of density 340 kilograms per cubic meters has a mass of 60 grams. Calculate the volume of this object, which therefore means that we are finding the space the object occupies. Of course, you know that you must first list your values. Taking the numbers out of the words is very important, and it will allow you to see the question in greater detail. After listing your values, you have to look to see if there are any quantities that needs to be converted to their SI unit form. In this case, you realize that the mass was given in grams, so you will have to convert it to kilograms, because grams is not the SI unit for mass, and we always strive to convert units to their SI unit form. The next thing to do is to write the formula for density. Density is equal to mass over volume. But because we are finding the volume and not the density, we will have to transpose this formula to make what we are finding the subject. So transposing the formula to make volume the subject gives us V is equal to m over rho. After which we have to substitute the numerical values for the mass and the density. And this ultimately leads to V is equal to 0.06 kilograms divided by 340 kilograms per cubic meters. Then you just simply work it using your calculators. Our final answer for the volume or space occupied by the object is V is equal to 1.77 times 10 to the negative 4 cubic meters. One should also pay attention to the fact that the kilogram in the numerator cancels the kilogram in the denominator, leaving the answer in cubic meters, which is the unit of volume. Taking a look at this other example, we see that we are being asked to calculate the mass of the cuboid that is shown below if its density is 500 kilograms per cubic meters. As you can see, we start by listing the values. Always list out your values. It allows you to see the question more clearly. So the density is 500 kilograms per cubic meters. Then we're going to be listing the length, the width, and the height of the cuboid. all of which is listed in centimeters. But you know that you need to convert these centimeters to meters, because the SI unit for length, width, height, and depth, or any other thing that measures the distance between two specific points, is the meter. And we always strive to represent quantities in their SI unit form. One should also take notice of the fact that we always list the value that we are asked to find and put a question mark beside it. This is also important. The next thing we should do is to write the formula, where density is equal to mass over volume. Since we are finding the mass must become the subject. Anything that you're finding must always become the subject of the equation. So, m is equal to volume times density. And this equation is telling us that we need both the volume and the density in order to find the mass. But while the density is given in the listed values above, the volume is not. So we will first have to use the data given by the question to calculate the volume, and then use this volume to calculate the mass. By extension, volume is equal to length times width times height of a cuboid. We have the length, we have the width, and we have the height. So we are going to use these values to find the volume, where V becomes 0.06 meters times 0.04 meters times 0.02 meters. And this gives us our volume. But now that we have our volume, we are going to substitute it into the equation mass is equal to volume times density. And this will allow us to calculate the final answer, the mass. Notice, however, that the cubic meters cancelled each other out, leaving the answer in kilograms, which is the SI unit for mass. Another quantity that is important to physicists and engineers is that of relative density, and it measures how many times a given substance is denser or less dense than that of water. That is, it is a ratio of a substance's density with respect to water. The formula for relative density is the density of the substance divided by the density of water, and it is said to be a dimensionless quantity, which basically means that it has no units. This arises from the fact that in the equation for relative density, the unit for the density of the substance in the numerator and the unit for the density of the water in the denominator is the same, and will thus cancel each other out, leaving only a numerical value for the relative density. One should also understand that the density of water is taken to be 1000 kilograms per cubic meters, which is the same thing as 1 gram per cubic centimeters. If the relative density of a substance is more than 1, then this substance is denser than water. But if it is less than 1, then its density is less than that of water. With that being said, we have come to the end of today's lesson on density. Please remember to like, share, and subscribe, guys. And do not forget to click that notification bell, as we will be going through numerous topics of which you do not want to miss. Have a nice day and a blessed one. Thank you.